Morning, guys. Good afternoon. I know we have plenty of folks around the world joining here. Um, Kevin, do we start? Are we going?
Yeah, we're good to go.
Okay, perfect. Awesome. So, welcome to the Impact webinar for Impact Innovations, part of the sponsor series for CSAT, CSAT and LSAT coming up. If you guys have any issues with the audio or visual, please reach out to support@csat.com. They'll be able to help you with anything there. I know we have a few more weeks before CSAT and LSAT. Looking forward to seeing all of you guys here. And I hope this webinar helps kind of set up the excitement for that. I'm certainly looking forward to it. A reminder, if you haven't signed up yet for CSAT and LSAT, please do. We'll drop a link in the chat to help there. Yeah, looking forward to seeing all of you guys and hosting you guys here in Worcester. This will be great. So throughout the webinar, while Jan and Leo over at Impact are talking, please drop any questions you have into the chat. We can bring those up at the end and extend the conversation there. So without further ado, I'm happy to introduce Jan Thomas and Leo Holzengasser over at Impact. They'll talk you through some of the exciting stuff that they've been working on since last year and some of the stuff that they'll introduce at CSAT as well. So over to you guys.
Thank you, Rufus. Good morning, good afternoon, everyone. So my name is Jan Kondas. I am working at Impact Innovations as a research and development engineer for more than 10 years. Or I am metallurgist originally, and I am working basically with the cold spray field and the cold spray technology for almost 20 years. That's from my side, and I give over to Leo.
Hello, everybody out there. My name is Leo Holzgassner. I'm co-founder, co-CEO, and co-owner of Impact Innovations, and I'm and as well technical director, and I'm involved in code spray almost 20 years.
Okay, so let's start our today webinar and presenting. Today we will shortly talk about our latest code spray hardware developments and their effect of these hardware developments on the application developments and impact innovations. So let me first shortly introduce Impact Innovation. For those who does not know our company, we are a German code spray equipment manufacturer focusing on high pressure code spray systems for industrial application. The company was founded in 2010, but many of the employees has longer, more than 20 years experience with the code spray field. We installed more than 100 systems, code spray systems worldwide. And our headquarters is located about 60 kilometers east from Munich in Germany, and having around 1,500 square meter production area and 750 square meter office space, where more than 50 people is working daily on design, manufacturing of code spray equipment, and research and development and application development for different code spray applications. From the more than 100 code spray systems sold worldwide, is about 50% located in Europe, about 1/4 in North America, and about 1/4 in Asia Pacific region. Most of the code spray systems sold recently are used in the industry, but there are still many systems sold in the past which are installed as industrial research or academic facilities. The main field of the impact code spray systems utilization is in automotive industry, aerospace and space industry, for electrical components and for household products, specifically for inductive coatings or cookware. Our in-house R&D facility, spray laboratory, has more than 10 years of intensive experience on application development and material research. We have an experience with a wide range of materials. Most of them you can see in the table on the slide, but there are several others. We have experience with many alloys, metals, polymers, and some ceramics. You can see also a few photos from our material characterization laboratory and also the spray lab. As first, I would like to introduce our EvoCSII cold spray system, which is a modular high-pressure cold spray system with a system architecture meeting the highest industrial standards. But it is also convertible to portable version together with the portable adapter, enabling operations at places with limited accessibility. And here I would like to give over to our CTO Leo Holzkastner to introduce the heart of the cold spray system, which is basically the control, the gas and electrical control cabinet, as you see in the middle of the image, the control software, and the process monitoring and communication capability of the system. So Leo, it's yours.
Thank you, Jan. As Jan already said, in the new EvoCSII system generation, what we have introduced in 2020, we are trying to follow a clear system architecture where we have a modular and flexible solution for, especially for the industrial use of 24/7 operation. We have in this system a centralized control unit and gas management unit with a centralized control CPU. All external components like powder feeders, guns, water cooling units, powder heating, everything what we have externally, what we call external component is connected to this centralized control unit. That because we want to control from one control software and from one control CPU all the external components. Due to that, we can specifically set up the system for the specific applications. And we have an easy integration of additional new hardware because we can easily use the existing interfaces for new powder feeders, for new can, for further developed equipment. We can use in this system up to 4 powder feeders, single or in parallel. We can run in the system process gas, nitrogen or helium. There is one special solution what we have as well is that we can run 2 guns in one system to increase the throughput, powder throughput in one system. And we work as long time on the Siemens platform Simatic with on the Simatic 1500 SP. And our control programming software is Siemens TR Portal. Jan, next slide, please. And we just now have introduced our new operating software called EvoOS, where we try to implement all the new standards, what is necessary to fulfill all the requirements of the new IoT requirements. That means we have a central software to control all the components of the equipment with a organic software architecture to integrate easily new upcoming software updates. We have a very open interface to communicate with different other system components or automations. And as I already said, we programmed this on a Siemens TR Portal platform. And we have a new user interface where we call it tile design for the clear overview of all system components with different component pop-ups where we have then the detailed overview of the status of the different components. At the moment, we have 5 different operating modes like manual control, external control, or recipe control like this. We have We have a centralized process value and process tolerance input. We have a very extensive monitoring system to monitor and control all the process parameters and the specific tolerances. We also implemented a new recipe system for all process values and process tolerances, where you can choose also the recipes from an external controls system. As we had in the system, in the software before, we have a message center for all informations, warning and messages with a message history. And we also implemented there a diagnostic area where we can also implement diagnostic system, external diagnostic system as we have with the OSIA system, for example. Next slide, please, Jan. And I want to show you, I want to also go a little bit more in detail what we do with the process monitoring. First of all, we monitor every second more than 150 process values in a CSV file. That means we have a closed loop process control with all these data. We can offer already now preventive maintenance solutions. And also we invest a lot in machine learning to set up the full system for all the requirements of industrial 24/7 24/7 operation. What we also have implemented in this new software that we do cross-checking and the ratios between different process values. And if the ratio between the values are not in the right condition, then we give the operator alarm or a message. The monitoring is carried out by specific defined tolerances, what can be set up in the recipe. With this, we can also detect right from the beginning minor changes during the production. That means we can already give quite early the message to the operator, okay, in the next 1 or 2 hours, you have to change, for example, the nozzle, or you have to change something in the powder feeder. We also developed, I think Jan will say more in the following slides, but we also have developed in the last year and introduced to our system a powder feeder with a gravimetric feeding system, where we can also feed and control in a gravimetric mode, what give also more stability to the powder feeding. Each component of the equipment has an integrated data memory that we have all the everything what happened in the gun, in the powder feeder is recorded to this specific component, and then we can gain out of this data what we record there, more knowledge for upcoming software improvements. And we have a fully integrated interface for external process monitoring systems, like, as I said before, for the particle velocity monitoring from OSIA. Next slide, please, Jan. And on top of that, we have, we call it functional safety interface for the safety-related integration into a high-level safety control system, like e-stop integration and enable system integration. Then we have a seamless integration interface for the external operation of the impact spray system by a high-level control production system. That means if you have a production line where you implement our core cold spray equipment, you can fully control this by your higher-level control system. You can, as I said before, you have external receipt selection and external machine operation, transfer of the system status and system messages. And this is available for all common network protocols, for example, Profinet, Profibus, Ethernet IP, CAN bus, everything what is available on the market. And as a third interface, we have a OPC-UA, process data transfer interface. That means we can, in real time, transfer all the process relevant system parameters and data to for example, to a SCADA system or to a server platform where I can then further process all this data. I think, Jan, that's it. And I want to hand over.
Thank you, Leo, Thank you for the detailed explanation. I learned also something new from these few slides. I will be not as detailed in the next slides, I promise. So what is the result of this? Basically software and control units and automation. So this unique capability of the EvoCSII system led us to develop 3 fully automated turnkey code spray solutions dedicated to industrial applications where the need was for multiple systems. So the first one on the left top is the coating box dedicated for the cookware inductive coating. Then on the right side on the top, there is the coating box dedicated for the heat sinks with copper coatings. This is a fully automated both turnkey systems where the automation is also so that this full turnkey solution is developed by Impact and the software is developed by Impact, and this is fully manufactured by us and supplied to the customers. The third one is the brake disc wear resistant coating, which is basically very similar, looking like the cookware coating box. And this code spray, the Impact code spray coating for the brake disc are technically qualified by the BMW Group and other OEMs. And the Impact hybrid brake disc coating solution was selected as a preferred solution for the serial production of the BMW M cars. So all BMW M cars in the future, I think starting from 2027, will have a coating on their brake discs from code spray from the Impact EvoCS systems. For the future, there are more dedicated designs are in the pipeline for other industrial applications to manufacture from or deliver from Impact directly turnkey solutions where multiple systems are required, such as space industry or turnkey solutions, compact turnkey solutions for industrial or academic R&D facilities. As next, I will introduce our Impact code spray gun family, which is the Impact Gun 5.8, the 6.11, and the 6.11 angle head version. All 3 EvoCS generation guns have improved the water cooling design, and the main difference between the guns are the temperature and pressure capabilities. So the 5.8 gun means it can go up to 50 bars process gas pressure and 800 C process gas temperature. The 6.11 and the 6.11 angle head can go up to 60 bars process gas pressure and 1100 C process gas temperature. Both the 5.8 system gun and 5.11 guns are available with radial and axial powder feeding, while the the 6.11 guns are suitable to deposit the most challenging materials because they can handle the highest process gas temperatures and pressures measured as the inlet point to the nozzle. Such as we can with this type of guns we can deposit the most challenging materials like nickel-based superalloys, cobalt-based superalloys, titanium alloys, or some highly alloyed steels. As Lee already mentioned, all EvoCS guns has digital sensor technology for extensive diagnostics for component-specific data recording. A little bit more detail, the 6.11 angle head gun. This enables an axial powder injection at different injection point and maximum process gas temperature with a specifically designed cooling concept. That's the difference between the standard 6.11 and the angle head 6.11 guns. To avoid any material sticking or depositing inside the hot area where the powder is in, let's say, contact with before entering the powder, the nozzle, so the hot components. All EvoCS gun family guns has a wide range of additional hardware options available, such as pre-chamber, which you can see here in the middle, powder injectors, and different types of nozzles with different types of cooling sleeves. For those who are not familiar with the concept, the pre-chambers are the components elongating the distance between the powder injection point and the nozzle inlet. So the powder is traveling in the hot process gas and has a chance to a little bit preheat, and therefore upon the impact at higher temperature, the materials which are not oxidizing, then it leads to better particle deformation and better quality of the deposit. The combination of all these features allow us to work on application development to move the boundaries of the possible cold spray material properties. And this I will always, after each component, show some examples. So one of the great results of the EvoCS gun concept with the improved nozzle clogging, nozzle cooling design is a significant reduction and elimination of nozzle clogging, enabling large-scale coating or additive manufacturing applications of aluminiums or nickel-based alloys, and also depositing. So as you can see, we can deposit continuously more than 30 kilograms of aluminum alloys. This is our limit, what we tested so far, so it can be even more than 40 kilograms of Inconel 625 or AM application without any nozzle clogging. And also with this gun concept, we can deposit aluminum alloys in S-sprayed conditions with nitrogenous process gas reaching S-spray ductility for structural repair application. Also, you can see in the middle there is a bimetallic ring composing of copper chrome zirconium and Inconel outer shell, which is used for rocket combustion chambers. And as you can see, there is a cutout in radial direction. There is a cutout piece which is underwent 3-point bending test, and you can see that the piece was bended, but no delamination occurred between the material. So this part is heat treated, but this is one of the criteria to have adhesion strength between materials very strong. With the unique design of the system, we are also able to deposit copper with mechanical properties in S-deposited state using nitrogen as process gas at powder feed rates, let's say at low powder feed rates, which is in our case like 2.5 kilogram per hour up to 25 kilogram per hour, and reaching mechanical properties as bulk material. So you can see on the top left, this is about 2.5 kilogram deposition rate, 20% ductility, 250, 300 megapascal tensile strength. On the right side, 24 kilogram per hour, 250 megapascal strength, 15% ductility in as deposited state. So no heat treatment. Except that the adhesion of this material to the substrate, in case we are using pure copper, so soft ETP copper, is higher than the cohesive properties of this ETP copper. So basically, as you can see on the bottom image, during the tensile testing, the fracture occurs not in the interface, but in the substrate material, which is softer. This type of copper deposits has also excellent electrical and heat conductivity, opening many possibilities in heat exchangers and coolers. You can see we can reach 98% of international alloyed copper standard and 376 watt per meter Kelvin thermal conductivity. The next system component is what I would like to talk about is the powder feeders, which are available in two versions. On the left side, you can see this is a standard volumetric feeding system version, and on the right side, this is the EvoCS gravimetric feeding system version of the powder feeder. Both type of powder feeders are working on rotating disc principle with high and accurate powder feeding. The operating pressure of the powder feeders are either 60 or 80 bars, and the powder feeders are as well equipped with diagnostic options for component-specific data recording. The powder containers, which is this part on the top, these are removable, and this can without any tooling easily exchange and the materials, the powders inside, and clean the powder feeders or refill it without using any tool. There are different types of powder feeding disc, as you can see in the middle of the image, for thin uniform layer deposition or for high throughput powder feeding. The latest introduced powder feeder has a gravimetric powder feeding system with this in the right side, with permanent powder feed rate control to ensure constant powder feeding and different feed levels. Powder containers with lifting guys and optional lifting tongs for ergonomic handling of the powder containers are available. The powder feeders are possible to use in single mode or a dual mode or a quadruple configuration, where it can feed one cold spray gun or two cold spray guns, and also it's available both the volumetric feeding version or the gravimetric feeding version. From these multiple powder feeders, it's possible to deposit also mixtures of different materials. For example, in our R&D facility, we are using extensively the options of multiple powder feeders with multiple exchangeable powder containers or hoppers. So when we are testing different materials, different powders, different materials, different alloys, or different powder PSD, we can do all the tests after each other, just switching between the powder feeders and depositing different samples. You can see on this short video how the powder feeders can be operated in industrial scale. This is one of the turnkey solutions. So you can see the screen directly on the powder feeder, then manually just pulling out the sticks from can remove the powder container. The container itself is about 20 kilograms, so you can also, we are operating this manually, but you can also use this lifting device to move the container to a cleaning station where you can by hand open the powder feeder, pour out the remaining powder if you want to change the material. You can also disassemble simply by hand the powder container, blow out the remaining material from the container, fill in the new powder, close the lid, and put back. Or you can just have more containers and after each other replacing the containers, you can just test different materials. Yes. The unique powder feeding concept also allows us to feed materials at very high powder feed rates in industrial serial production. What is utilized in case of heat sinks or electrical components and leading unique deposition properties. I also want to show a short video about the speed of the deposition. So this is a 3 times accelerated video depositing a copper ring on a steel substrate. As you can see, the powder feed rate is 358 grams per minute, so 21.5 kilograms per hour. The efficiency of copper deposition is 98% plus. And also we are achieving mechanical properties of these deposits, as I already showed before, 250 megapascal strength. So 620 grams deposited in 1 minute 45 seconds. Yes, so basically it's a 3 times speeded up video. Then of course this is a fully machinable deposit. On the right side, also this very accurate uniform powder feeding resulting on the right side, you can see a deposition of columbium C103. It's an niobium alloy used for rocket nozzles, where we manufacture the demonstrator with a wall thickness of 1 millimeter. So aluminum membrane used, then deposited in 1 millimeter thick deposit. enlarged thickness at the flange, so at the end, at the throat of the nozzle, and then the aluminum mandria was removed by chemical dissolution. So this very uniform feeding system allow us to do very thin and very uniform deposits as well. As the next, I will introduce our EvoCSII powder preheating unit, which is an external component, increasing the powder particle temperature in the inert gas stream, which is resulting a better particle deformation and hence a better property of the material. This you can see on the top, yes, as an external component here. This powder preheated added value is, for example, shown on this nickel deposit, where we achieved depositing pure nickel with nitrogenous process gas maximum parameters with powder preheating. We are working with a deposition efficiency of 99%. We're reaching almost zero porosity. And as you can see, the tensile properties around 550 megapascal or close to 550 megapascal UTS and a bit over 2.5% ductility. Last but not least, I would like also to mention the possibility of a compact delivery of a cold spray system for in situ cold spray repairs, where we are utilizing also in combination with the so-called portable adapter, which is a remote nozzle connected to the cold spray gun, as you can see on the top image, which has a much higher flexibility, lower weight, better accessibility compared to our standard gun types. This setup we are widely using for aluminum repair, application development, and with this we are also deposited all the materials which is showing S-sprayed ductility and bark-like properties in case of aluminum using nitrogen as process gas. So this is from my side all. Thank you for your attention, and in case of any questions, we are open, and in case of any question, if you come in the future, just look out our email address and contact us.
Awesome. Thank you so much, guys. This was incredibly interesting. We have a number of questions in the chat that we can pose. One of them is on the copper. People are asking if the copper that we got you got those really good results with, was that processed in any way before you sprayed it? And secondly, were the particle velocities measured during those sprays?
We measured particle velocity, but honestly, I don't have the numbers in I would have to look up, so somebody can contact me and contact us and let us know and we can look at and send them the particle velocity. This is these properties were achieved with let's say standard gas atomized copper powder. So no special pretreatment were applied.
Gotcha. And then
and I think there was the question if this was really S-sprayed ductile copper. For sure, there was no heat treatment afterwards, pre-processing or heat treatment afterwards. This is an S-sprayed condition.
Gotcha. Wonderful. What do you think is the materials phenomenon associated with that really high ductility that you're getting out of the copper and some of the aluminum-based stuff as well? Usually those are quite brittle. So how are we able to get this ductility out of cold spray?
Yeah, so there is a kind of dynamic recrystallization partially of the material after deposition. We have some scientific papers also in collaboration with some universities published on this topic. Somebody can find with my name or with Impact Innovations, and bark-like copper deposition, something like this, where I also, let's say, describe the conditions as was deposited and what is how it behaves, which type of powder, PSD, and so on. But of course, it's a combination of particle velocity, a combination of powder, certain purity, to reach this kind of properties.
Gotcha. Good to know. And then kind of following on with the softer materials, but also looking at it says you were able to spray silver as well. A lot of those soft materials have difficulties with feeding. Have you guys seen any issues there? Have you guys been able to, it sounds like you guys have been able to overcome them if you have seen them. So how have you gone about working out how to feed those softer materials?
Yeah, so one of the ways that yes, silver is very soft. So in case of this rotating this concept powder feeders, after a certain times, it can be that basically some material is smeared to small chips, which can act in a certain way, like negatively in the powder feeding system. But of course, this time is relatively long until it happens. So therefore, in industrial scale, there are applications for cold spraying of large amount of silver. And this is can be solved by just exchanging these containers as you show on the image. So you pull out one container, put the second container, continue, and in between you can clean the powder container, and they remove all these kind of chips and continue with the spraying. Yes, so you can remove with a simple sieve, 100 micron sieve. So this is the biggest issue with the silvers, feeding problem, but there is not really a big issue with the material itself, just this kind of smearing some powder particles to chips.
Gotcha. Understood. Thank you. Then a question I had for Leo on the diagnostic side. What percentage of your customers currently use some of the diagnostic tools that you guys have? And what kind of customers are benefiting the most from those? Are they on the R&D side, pure research, commercial customers, that sort of thing?
Yeah, especially for this for the particle speed velocity management device, what from OSER in this case, what we have implemented fully in our. Maybe I forgot to mention this. This is fully implemented in our system. That means if you set some tolerances of the particle speed, for example, or and if you're out of the tolerances, we can either stop the powder, or either we can give a signal to the robot that it should move away. We have there different options, and for sure, I think we have already some applications and sold already some systems in the space industry, for example. For production of combustion chambers, where they want to detect on one hand for sure that you have the right particle speed is a very important value that you can guarantee your coating quality. And on the other hand, that for sure we spray their Inconel powders, and for sure Inconel powders tends to clog. And therefore we also use this tool there to detect in advance if there is clogging. If there is a starting clogging before we have really a drop in the particle speed, then we already shut down the powder and move the robot away. But I want to say on top of this, I think this is very important. We have developed, Jan mentioned this a little bit, that we have developed a new concept of our nozzles, where we are able to spray Inconel 625 more than 30 kg, or in hours. I think we have a customer in the space industry, they can spray now more than 20 hours in a row without clogging, and I think this is also a huge step for the industrialization of spraying Inconel for combustion chambers.
Excellent, thank you, Leo. And just to double check, you said these are now implemented. Are these only implemented on new systems, or is this an update you can get if you already have a system, get it updated to have these diagnostic tools in it?
You can update this on all the EvoCSII systems.
Gotcha. Okay.
Also the new control software EvoOS, we can update, or we can update, and then all the EvoCSII systems.
Gotcha. Excellent. Thank you. So I think we are probably good for questions there. It sounds like there's definitely a lot of interest in the really high ductility materials. So if you guys are able to share any more information about that, anything you're able to publish, certainly that would be really awesome. But other than that, I think we're good. So thank you very much, guys. This has been awesome. Really appreciate you guys taking the time to talk to us and help out with this webinar. So I appreciate that. And we're looking forward to seeing you at CSAT as well. To everyone here, again, if you guys haven't signed up for CSAT yet, please do. We're looking forward to hosting you there. But otherwise, I think we are good. So thank you very much, guys. I appreciate it.
Thank you. And we will also present on the CSAT, and we will present also on the aluminum with ductility. So that's one of the opportunities to talk to us or to see our presentations.
Excellent. Thank you, Jan.
Thank you very much.
Thank you.
That's good. Thank you, guys.
Bye-bye. Have a nice day.
Bye-bye.